Alrighty, and we're back for our last section. Rainbows. All right, so cool, so pretty, so simple. No, not at all. Rainbows are, I don't say mysterious, but they are definitely not simple. What happens is that raindrops that hovering in the atmosphere, okay, act as prisms, bending the light. And you're familiar, or perhaps, with the Roy G. Biv. Okay, Roy G. Biv tells you the colors of the rainbow: red, orange, yellow, green, blue, indigo, and violet. Right? And we see red on the outside and violet on the inside. So it's from the outside in. Giving you a second to look at that here before we... So it's a mixture of refraction and reflection. All right? And basically, okay, the light waves get bent a couple times as they come out. Now, here's the, without getting into the details about refraction and reflection, here's what I do want to focus on. The rainbow is a function of where you're standing. You and the person standing next to you, be it your friend or a little kid or whatever, you say, "Oh, cool, look at that rainbow." When they turn and look at it, they don't see the same rainbow you do. It's still going to be a rainbow. It's not going to be, a zigzag or a circle or a square. It's still going to be a rainbow, but it is not the same rainbow that you see. Rainbows are functions of perspective. Okay? If they're shorter, if they're taller, if they're farther back, if they're closer, if they're not standing in the exact same spot that you are, at the exact same height, with the exact same head inclination, they're seeing a different rainbow. Does that matter? No, not at all. Because, it's fun just to look and see the rainbow. But it is, I think, important to acknowledge or to recognize that it's a function of optics. It's a trick of optics. And as such, everybody sees a different rainbow, and I think that's pretty neat. It's a function of angle. All right? And that certain colors come in at certain angles. Please don't worry about what angles. All right? Each individual color comes in at. Please don't worry yourselves about that. But do understand that different colors are seen at different angles. And that entire spectrum, they chose red and violet here for a good reason. Roy G. Biv, starting with red, ending with violet, okay? Happens between 40 and 42 degrees. All the colors of the rainbow come in between 40 and 42 degrees. So we told you that the light gets bent a couple times. I think it's the next slide here. If it's not the next slide, I'm going to tell you. Oh. All right, so you have to have, I can't believe I don't have a slide for this. You have to have your sun you have to have the sun at your back when you are seeing a rainbow. That's another key component. It helps, obviously, if it just rained, to have that water still in the air. All right, but you need to have the sun at your back, and this is kind of where, going back to everyone has a different rainbow, why they're so hard to follow and to get exactly where they are, because as you move, it moves, and unfortunately there is no pot of gold at the end of the rainbow, and all those other ideas. There's an old poster that I remember very hazily from the 70s as a little kid growing up, and these little guys, like a construction crew, a painting crew, painting a rainbow. And I've never even, on eBay and all the images floating around there on the internet, I never have been able to come across that one. But I think that would be simpler to explain than how these rainbows really do happen. So, speaking of which, all right, I want you to follow, let's see which one of these it is that I definitely want you to watch, and then if you dig this stuff, you can watch the other one. Let's see, Science of Rainbows. I know you can't hear the sound.
We believe in good we can all afford.
Or at least very well. It is okay to be smart.
From coloring books to record covers, rainbows are everywhere. I bet you can even remember the colors.
I do want you to watch this very first one, okay? Definitely watch this one. This one, it's up to you. Oh, wait, is this not G? Hold on. I thought I had this one guy in here, G-Sauce. Silly name.
This episode is brought to you by Squarespace. Do you remember how rainbows form? There's a ton of videos out there that explain them. The physics is pretty easy. Light enters tiny water droplets, bends,
I forgot that I added this
bounces, bounces, bends again, and different colors end up in your eye. Easy, right?
Okay, so that G-Sauce guy is in the lecture, the next lecture about energy in the atmosphere. He talks a lot about color. And this guy, I think in the first video, references his video. That's how I found it. But that gets pretty far out. So do take a couple minutes and watch both of these videos. You see this one is all of barely 6 minutes, and this one comes in at 4 minutes. And that's 10 minutes, and basically when you add that on to the 8 minutes that I've chattered through right now, that brings us up to a good-sized final part of the lecture here. So, please take 10 minutes right now and watch these two videos. I'll put the links in the lecture, so you can follow them a lot easier than just having to retype all this garbage here. Take care. Be well.